Hi class, today we'll be discussing energy. This is a very important chapter because it builds upon itself in the next couple of chapters. So make sure you thoroughly understand energy and pay attention to the problems that are worked out and how they are worked out. Energy makes objects move is defined as the ability to do work. There are two types of forms of energy. There is kinetic energy, the energy of motion, and there's potential energy. Energy of motion is easy. If something's in motion, it's considered kinetic energy. Potential is a little more difficult because it's basically energy. Excuse me, my cat's bothering me here, trying to move him out of the way. Energy possessed by an object because of its position. Now that makes it is a little bit more confusing because it has to do with position and not necessarily an active, something easily seen by as such as kinetic energy. So if you look at this roller coaster here, you can see that at some points the kinetic energy is high and the potential energy is high. When it's going up, this is motion. So the potential energy is being built up until it gets to a point that it's forced to change into kinetic energy. And then this goes down. You see the potential because it's gone. And then as it starts going up, the potential energy is being built up again. Same as a dam. This dam here, this water that is stuck behind a dam has a great amount of potential energy. Once it changes to kinetic movement, it will cause a lot of damage. So kinetic energy is the energy of motion. Examples are swimming, water flowing over a dam, working out. Anything that's motion is considered kinetic energy. Potential energy is the energy stored for use at a later time. It is determined by the position of an object or the chemical composition of a substance. So examples are water at the top of a dam, a compressed spring, a chemical bonds in gasoline, coal, or food. We eat food to give us energy. So that food is potential energy. The water at the top of the dam, has potential energy by virtue of its position as, I don't know why I can't, my throat starts always acting up as I talk. I can't clear it. As the water falls over and down the dam, the potential energy is it's converted to kinetic. It's no longer potential because the position it's in is no longer there. So let's take a look at these and determine if they are potential or kinetic. Rollerblading, that is an activity that's active, so that's kinetic. Peanut butter and jelly sandwich, it's food. When you eat it, it would be potential energy until you need it to use that energy. Mowing the lawn is it's an activity, so you're being active, that's kinetic. And gasoline is potential. Why? Because you put gasoline in your tank and it is used up as you drive. So when you're first putting gasoline in a tank, it hasn't been used up yet. It's potential energy to get your car to move. Now, we need to understand heat and energy and how these are associated. So heat is the energy associated with the movement of particles. The faster the particles move, the greater the heat or thermal energy. So let's take a look over here. What you see as we see some kind of substance, we can say it's even an ice cube as what's going on here. But what we see is a solid, and the solid is in a fixed arrangement. It has it's very limited in its motion. But when you add energy, such as in the form of heat, you're giving energy or any type of energy, it's going to force these molecules to move faster and faster. So it's giving it's supplying energy into it, and the molecules are being forced to move and move. And the more that they move, the more friction they're giving off, which causes the heat to the temperature to rise until eventually this agitation becomes so strong that these bonds break. And you can see the temperature goes even higher. So given an ice cube, as heat is added to the water molecules, they are moving slowly. But given enough energy, the bonds, the attraction that keeps them together will break off. They'll still be water molecules, but they won't be as attracted to another water molecule, and they'll become a liquid. Units of energy. Energy is measured in joule. I have it down here. You can see it's pronounced joule with a capital J, or kilojoules. Small k, capital J. 1,000 joules. Units of calories. This is also another units used. It's a small letter C, calories, or kilocalories, 1,000. The calorie is defined as the amount of energy needed to raise the temperature of 1 gram of water. So if you have 1 gram of water, we calculate how much energy is needed to raise that temperature of water by 1 degree. So here are our units of conversion. So we have 1 cal equals 4.184 joules. This is exact, and we can set them up as equalities. Excuse me. How many calories are obtained from a pat of butter if it provides 150 joules of energy when metabolized? So this butter is potential, and then we're trying to figure out how much energy it's applied. How many calories does it give off when it's changed into different energy? So we need to pull out what we know. We know that it has 150 joules, and we need the calories. So we need an energy factor. So we start out with the problem in joules, but we need to convert this to calories. So we need joules. We start off with joules. We need a conversion, and then that should give us our calories in the answer if calories is units. So here we are. We have what was displayed a couple slides ago. We have 1 calorie equals 4.184 joules, and we have to determine which way we need to set this up so that our answer is in calories. So here it is. We start out with 150 joules. This is 2 sig figs because there's no decimal here. So this trailing 0 is not part of this. It's a place value. So we have 2 sig figs. We set up joules. This is exact, 1 calorie. So our answer is 36 calories, 2 sig figs. So 36 calories is obtained from a pat of butter if it provides 150 joules of energy when metabolized. And that's it. Thank you.